Welcome to my channel, Laying Down Data, where I share my thoughts on being a data professional. In this first video, I want to explore the choice or the option of selecting a programming language to do data work. Now, whenever I say I am a data professional that uses Golang to do data work, I'm usually hit with how or why. In this video, I want to walk you through how easy it is to actually use Golang to get data work done and possibly answer both the questions of why do I decide to use Golang and how do I actually use it. So let's get the why out of the way. I can explain why a programming language such as Golang is more performant than Python, or how most data products are actually explored and consumed over the web, so why not use a programming language designed for the web? But the reality is, as you grow as a data professional, a bunch of people are going to have their own opinions as into why their programming language is the best language, and here's mine. I like to program using Golang, and it's really that simple. And I believe that if you enjoy a language and want to get into data work, you should find a way to develop that language or to develop your skills with that language to get that done. And you have to remember that Python wasn't selected for a higher reason outside of the people who were early adapters to the data space enjoyed using Python to actually write and develop code. And they developed an ecosystem to do just that. And here is the how. My plan is to introduce using Golang for data work in a series of short videos. And in this first one, I want to introduce dataframes in Golang and express how simple it is to get up and running. And in future videos, we will explore more complex topics, but by the end of this series, I'm sure I can show how Golang can be used for data work. With any video of this type, I need to make some assumptions, so I want to share those with you right now to make sure that we're all on the same page. So first, I'm assuming that you know the basics of Golang. If not, let me know in the comments if an intro video will be helpful. I'm also assuming that you have Golang installed and access to Kaggle, that you know the basic data terms and ideas, and that while data work with Golang may be new to you, programming is not. If any of these assumptions aren't true, pause and come back to this video once you're ready. So for this video, we will have a simple setup. Our data file will be called customer_churn.csv, which we will get from Kaggle. The main.go file will be our main entry point, and lastly, I will use utils.go to hold all functions and variables. So let's have a quick look at the customer data from Kaggle. Quick trip over to Kaggle shows us our data set. Here we're using the customer churn classification data set to do the work that we are going to explore in this video. The quickest way to find the data set is possibly looking for this individual, see that it was updated 2 days ago. And essentially on Kaggle, you can scroll down and actually click this button to download your data set. Taking a quick look at our data, we can use the same screen here to get a preview so we can see our row number, our customer ID, surname, credit score, etc. Now, if we were to jump into VS Code where we will actually have all of our functionalities, including our main.go and our utils, which I'm calling functions.go here, we'll see that we have our customer churn data, and this is actually the shape of our data set. And if we were to jump into our main.go file, we will have a simple setup. We will import what we need and have a single function called main. In this function, we will call other functions from the utils.go file and explore the output of all of our code. If we take a look into the utils.go file, we'll see that we're holding all of our functions, variables, and custom types. I personally like to separate my working functions from my main functions in this manner just to make my code more readable. But the reality is you could combine everything into the main.go file and just have one big massive code block. Now that we have our data, we can explore that there's 3 different ways to actually get our data into a data frame using Golang. The first and personally my preferred method for anything in production is to get our data from our CSV, import that into a struct, and then from that struct load our data frame. Now this provides more control, but it's also more verbose, and it also gives us the option to transform and handle missing data. Now, because of the size of the actual data file itself, or rather the code supporting the data file, I decided to make this second recording so that we can explore the code together. So when you're utilizing a struct to actually load a data frame, one thing that you need to keep in mind is that we are defining upfront what our column names are, what their types are, and essentially we go through and create this custom data type within Golang. Here I'm making this function called load data struct, which takes in a file name, which is the path or the file path to the actual CSV file here, and I am returning a dataframe.dataframe object with this function. Up top, we're calling a master data object, and we're saying that this master data will be a slice of our actual data. So our custom data type here is called data. We are opening up the file using that file path. We're checking for errors, and here we're using that defer statement to actually say, hey, keep this file open until I'm ready to close it. I really think this is handy and a nice way to clean up. I'm creating a new reader, and then down here, I'm actually looping over all of the data that is generated by this new CSV reader. This records equals 0 is just a way for me to keep track of which row I'm on, because what I don't want to do is include my column headers as part of my actual data set. So that first header or that first record, which is going to be the 0th record, will be our actual column names. And I want to make sure that I'm skipping over that, and we'll see that come into play later. Here I'm doing essentially an infinite loop. So I'm just doing a for loop here. And what I'm doing is going over each of the records. And each time I'm going over the record, I'm checking the error to make sure that we're not at the end of the file. If we are, we break out of this loop, and that's how we can actually progress the code. Here, I'm checking that records up top where we declared it at here to make sure that if it is the 0 record, I just want to increase records by 1 to break this condition, and then I want to continue. Once this condition is cleared, I'm then really making use of each of the data elements within that slice or within the actual row that I'm looking at. I'm switching on the ith, which is just the ith position within the data, and I'm using case statements to handle all of our logic. The reason I prefer this method is because here I'm able to do two things. One, I'm able to validate that the ith record is of the data type that I'm expecting. If it isn't, I'm able to implement some error handling, which here I'm just simply saying if it's not null, meaning that I wasn't able to convert it from a string to an integer, I want to replace that with a -1. But I can take this a step further and actually add range validation. So for example, our 0th element should be our row number. If I know that my row number, for example, shouldn't be above 10, I can add that logic here and say, hey, if row number is greater than 10, I want to handle it in a very specific way so that when I check the data at a later point, I can validate my data quickly to make sure that it's in the shape, in the format, and of the data types that I'm expecting. So we do this for all of the data that we're pulling in with our CSV reader. And then at the end, we're just attaching these individual data elements to our master data. Lastly, we're using load structs to actually load the data frame with them from the master data, which is a slice of our struct. And if we actually go to load struct here, which let's see if I can get this to work with me. Go to load struct here, we can actually view the code. So by clicking on this link, you should be able to open up a window in a different screen. Here, it's not going to do that because I'm recording a very specific screen. But clicking that link should take you to the documentation where you can see how easy it is to actually load the structs. Another option we have is to take our CSV and load a slice of slices into a data frame. Here we're going to create our data object, which we're going to call master data file, which is a slice of slices. We're then going to load or open up the data file. So here I'm using file name, but this would be our customer churn.csv data or the path to that file. We're going to check for errors. And then we defer the closing of the file. And essentially what we're saying here is just keep this file open while I'm working on it. Once I'm done, please close it. Next, we create our CSV reader. We read all of the data to our master data file or our master data object. And then lastly, we use load records from Gota to actually load our data frame. And that's it for that step there. This is quite possibly the simplest and probably the preferred method that a lot of you are going to use, and I 100% understand why, but I also encourage the exploration of using structs just for that control in any production setting. But here we see things are much simpler. We will simply open up our data file. We keep it open, so we use the defer to actually keep that file open and make sure we close it once we're done working with it. And then lastly, we just use the read CSV on that file to actually load our data frame. So now I want to explore some of the most basic and possibly the more frequently used methodologies or tasks you will have to do as a data professional, but we're going to use Gota to actually do a lot of these steps. So first we want to look at how do we select the first N records. Here I'm doing first 5 records. How we can view our column names, how we can actually see our data dimensions, view our summary statistics, add columns to a data frame, filter the data, select specific columns from the data frame. We want to look at grouping and aggregations using Gota. And then lastly, we want to explore how we can actually save our CSV file for future work. So the first is really simple. We are going to use subset on our data frame, and here you will notice that I'm using a slice of integers, and this allows me the flexibility to select the index, the row index that I actually want. So here I'm doing 0, 1, 2, 3, 4 for the first 5, but there's nothing stopping me from selecting the first row or every odd or every even row index number. I have a lot of flexibility with this method here. I'm also using the fmt.println just simply to display our content in our console so that we can see what that content looks like. Next, to select the column names, we can just use the .names method, and this gives us a list or a slice of our column names within our data frame. .dems will tell us the shape of our data. .describe will actually give us our summary statistics. And from previous work that I've done, these methods pretty much covers the first, verifying your data is in the shape that you expected in, that your columns has the information that you actually want to see, and that you're actually dealing with the correct data types within your data frame. How to add new columns using Gota. So here we're doing something really simple. We are creating essentially a slice of ones that will be the length of our original data frame. You will notice that I'm using slices.repeat, which is, I believe, a feature that jumped into Go 1.23. So if you don't have that version, this may not be available to you, but if you do, you should be able to use slices.repeat, which takes in a slice and then repeat that slice the n number of times provided. Here, I'm using the length of our data frame, or the number of rows within our data frame, to do that repeating. On the next line, right below multi-ones, we see we have a new data frame called df_new. I'm making a copy of our original data frame, and then I'm calling .mutate. And from mutate, mutate takes one option or one input, which is a series. Here, I'm calling series.new to say I want to create a new series. And the data that I want to load into the series is the multi-ones. The data type is of integers, and then the column name is all ones. And then lastly, I'm printing that new data frame out to actually show you guys that we were able to add that new column. Next, filtering data is a common operation. Golang and Gota does things a little different, and I believe that this is closer to, I want to say, the direction that Python may be going in. There's a data frame library that has a similar signature to this, and I think that this is a phenomenal signature to handle things. But again, we're creating a new variable called df_filter. We're going to make a copy of our original data frame. I'm calling .filter after that so I can kind of string these methods together. And in .filter, I'm calling dataframe.elf, which is our actual thing that we want to filter. So I'm specifying the column name. Here is exited. The comparator is that this column name must be equal to, and then the thing that I'm comparing it to is 1. So this statement says that I want to filter this data frame on this column where it's equal to this input, in our case is 1. And then lastly, of course, I'm printing that out to show that we're actually able to see that filtered data frame. Now, if we're selecting specific columns, here we can just simply call our data frame .select and then provide the name of the column we want to select. Here I'm selecting all ones, as that is the data frame, or that's the column that we just added. And then here's something that I noticed is frequently skipped over when speaking about or covering Goda, which is how to handle aggregations. This may not be the most efficient way to do it, but this is the way that I've always done it, which is create my copy, create my grouping. So telling the code that I want to group this data frame by gender and exited. Here I am creating a new variable called df group underscore filter. And then from the grouping that I created up above, I'm calling that aggregations. Now, Goda is a little different in that, at least when it comes to aggregations, in that they have the aggregation types available to you. And these aggregation types range from 0 to 7. So you can do things such as sum, counting, averages, I believe mean or mode. You also have max, min as well. Here I'm calling the 7th aggregation method, which is the count. And then I'm specifying which column we want to count. Here I'm saying I want to count the customer IDs grouped by gender and their exit status. And then lastly, like with all other examples, I'm printing that out to the console so that we can review it. And then the last thing we want to do is typically save our data. So we create our data file. So we call the file error os.create to create our CSV file. We check for errors, and then we use the .write CSV file to actually save our data. All right, with all of that covered, let's take a look at all of our code together. Here we can see that we're using the load data CSV method within our main.go file. Let's pop over to functions or funcs.go to actually see what that function looks like. So if I go to load data CSV, you'll notice that it is the exact same code that we covered in the PowerPoint presentation not too long ago. From there, we can print the first 5 columns or first 5 records. We can see our column names, the dimensions, the actual summary statistics, and then we also can add our new column of information, right, using that mutate method. Here, I provide you 2 different ways to actually filter information and view it. So this first one here is just a very simple filter, which is the one that we covered in the PowerPoint. And here I'm presenting that. This is to actually view the column. And here's the more complex filter where we're using a filter aggregation. And here we're simply saying that we want both of these statements to be true. So the exit status must be 1 and the gender must be male. So we can use this filter aggregation to actually have multi-filters set up on our data frame. Here's our grouping, here's our saving, and this is essentially the entire, all of the functions that we're covering in our actual presentation. So now over here, I'm going to do go run period. And if you notice, I'm using period because I have multiple files, multiple Go files here. And this is just a way to say, hey, run everything that you can see. Will present us with all of our information. So if we go by this one by one, we can see here's our data frame. We can see the names, right? So this is the columns that we actually have. Here are our summary statistics. Here is, forget which one this is, but essentially what we're able to see here is that we're able to get everything. Oh, this is our data frame after we've added the all ones column. And we're able to just go through and validate that all of the transformations and the functions that we're utilizing or the methods that we're leveraging is actually working. Here's the grouping and aggregation part that I think is frequently skipped. But I hope that you got some value out of this video and that you see that using Golang and Gota isn't really difficult to do data work with, and that actually with Golang as your language and Go as a library, you can actually do much of the same functionality that you can do with other programming languages such as Python. I hope you enjoyed this video, and if you have any questions, please feel free to ask me. But if not, I hope you guys tune in for the next one. Thank you.